Hey, our project's called WeatherMesh. The team is myself, Tessa, Nicole, who couldn't be here, and Camille. We decided to take on the challenge of Cool It, which is to help monitor the temperature difference between urban and rural areas. It's also known as the heat island effect. We wanted to find a better way to more efficiently cool down urban areas where everybody's running their air conditioning. We might get a brownout, stuff like that. So the solution was to build a small device, this here actually, and have an API to store that data. The API was built with Node and Mongo, which was mainly Tessa, and the front end was done by Nicole and Camille. And there's the Arduino-based weather station. Sorry. Some of the challenges were getting the hardware to communicate with the API. That was pretty tough for us. And then building out the front-end maps, which Camille had a lot of trouble with. It was pretty interesting to play with the maps and try to find ways to get dots on those maps and just start there. And then our entire scope of our project, it started as just getting this small hardware device to communicate with the API. Then it became a website, and then we wanted the website to be kind of the Facebook for temperatures, where everybody can build their home weather station and start to input data. And I think that's where the future's headed for this project. This is the weather station itself. It's based on an Arduino Red board because it's pretty inexpensive. The wireless board was probably the most expensive part, but still pretty doable if you wanted to mass produce these. A tiny humidity sensor and a barometric and temperature pressure sensor, which is actually does -40 to 120 degrees Celsius, which is pretty awesome because that was probably the best one I found out there. Yeah, so that's, and now we have our demo. Did you want to take over?
Okay, so let me just pull up the demo here. Okay, so this is a currently working version of our map, just displaying sensors around the area of Ontario. And currently it's actually pulling or getting data from the current JSON file, which Heather and Tessa can speak to a little bit more. And again, for every single sensor or data point, we have the information that you can hover over and receive in real time. So currently we have the current temperature, which currently about every 10 or 11 seconds updates. So again, Tessa can talk a little bit more about how that was set up. And we've already talked a little bit about the challenges of setting up D3. This is the first time that we've really worked with this library. So it was a little bit of a challenge, but I think overall the future would definitely be showing all of this data not only in real time, but also comparing it by time through an animated scale. And again, the more data that we get and the more people that participate, the better and stronger this app is. So that's pretty much it for the demo.
So we decided to make an open API that eventually anyone who could create one of these basic weather kits could connect it to our API so that we could display data from potentially a lot of different sensors. And then ideally, if you had them all over a city or all over an area, you would actually be able to see the differences in temperature between different areas in a microclimate. So the way it works is that if your weather sensor, ideally we're thinking you'd have to get an API key to be able to connect, but you make a post request to our API and then your sensor becomes one of the sensors in our system, and so it can start sending data, and then your sensor would appear on the map and start transmitting the data for temperature, humidity, and barometric pressure, along with all the other sensors.
Yep.
Is that everything?
Yep. Oh, that's all good.
Alrighty.
Yeah, so I think we're ready to take some questions.
Okay, I've got a couple.
Sure.
Now, did you intend to have people have a version of that or make their own one of those?
This is completely open source, and all the pieces are open source as well.
So you'll have the design for that so people can set their own sensors out wherever they live,
yeah,
right?
Yeah.
Okay, and then so I just see that as a product in itself at some point.
Yeah, it is
that
for sure.
You create your own mat, and then people just order them from you. Those
Yeah.
who don't want to build it can just order their own island, you
Yeah.
know, and take that.
That's definitely the starting point for us. And I think we just want this to be a starting point for people who might not be able to buy it from us, or they can just build it themselves or put their own spin on it and build it the way they want it to be.
And then the data set that you had trouble with, what was the data set?
Oh, so that was building out the maps.
Oh,
So I
building.
think that Camille can speak.
Yeah. Again, it was the first time that we had worked with TopoJSON and GeoJSON files. So just getting the shake files from natural Earth data, which I believe was the biggest challenge. Just getting them into QGIS and just figuring out how to convert that data was kind of our biggest challenge. But beyond that, it was, again, just dealing with figuring out how to set up the data points right now as we go. So.
Just a quick question. Great idea, or comment rather. Great idea about. I see a lot of potential for classrooms as well, especially in an environment like here at the Science Center. Did you mention the estimated cost for the kit and production materials and so on?
The prototype cost about $100, but that was because this shield is more expensive than the smaller type. I think we could get it down to around $40 to $50.
Okay. Thank you.
That's it.